Greg, thank you for joining us at the last minute.
No problem. We live on the edge, man.
Yeah. Hey, Charles.
Hello.
Hi. Thank you for joining us today.
Sure.
Eric, you have the best background so far.
Who does?
What?
Eric.
That's
I have the
campus
best-
that I haven't seen since March. So
I have the best special guests though.
yeah, I
You
can't
are
compete
the
with
best
that.
special guest. Oh
Hey, baby.
my goodness.
My wife.
Look at them cheeks. Oh.
Yeah. Say daddy works in the industry, so we're gonna learn something.
All right.
Yay. Get you started off right.
Precious. Hi, Josh.
Hey, Josh.
It's dark here, but I'll have to see if I can prove that somehow.
I know my office is the exact same way, Josh. I literally have to move my entire desk the opposite direction, bring my chair on the other side, switch everything.
no. I'm in the floor of my bedroom. My office right now is being occupied by my wife on another Zoom call. So I went room to room in my house trying to find somewhere where there wasn't a noise-making animal and or human that I could do this. So this is as good as it gets for me right now.
That's all right. We appreciate you being here.
Zoom problems. It's a thing.
Right. Hey, Randy, it's good to see you.
It's not another person or a dog or a kid or anything, but I finally caved because Laura's really wanted a Roomba. I'm like, fine, maybe I'll pick up all the dog hair in our house. And she's like, yeah, it's pretty noisy, but it just runs while I'm gone during the day. And I'm like, hello. So now I have this little black puck running around underneath me. At least the floors are clean. So I mean, we got that.
What do the dogs do when it runs?
I think it has reduced the quality of life for my dogs.
I could only do it. I would have to close the doors for the dog because she was
Yeah.
terrified.
They do not like it. Yeah.
My sister had one, and then their dog peed on it to establish dominance.
Ooh.
My
It
pit bull.
did not survive
I
that.
guarantee it.
Hey, Charles, I'm looking at your website, Eco Panels. Is it a SIP system?
I hate the word SIPs, but yes, it is a structural insulated panel system.
So what's the better way to describe it that you do like?
We're eco panels. We're
Eco
panels
panels.
where so the SIP market is 90% controlled by the polystyrene products. And I've had builders run away from me when I mentioned the word SIPs because they've had bad experiences. And so we're trying to reinvent that space with the superior product.
You'll
So
get to
what
hear-
is,
You'll get to hear more about it.
Now, what do you do?
He's going to do he's one of our presenters also.
I'm a researcher, academic professor at the University of Denver, and one of the big research projects I'm working on is a stick built versus alternate construction narrative and cost analysis. And so, we're trying
So
to.
we had two structures at the 2017 Solar Decathlon in Denver using our panels.
Excellent. Which teams?
UC Davis and Northwestern. Northwestern was our primary one. They won two first-class awards.
Excellent. I'll go back
You
and
guys
look.
make your own
And
panels?
we were actually the only panel system in the entire Solar Decathlon. Then the next year, 2018, we were in the International Solar Decathlon competition. Virginia Tech submitted for Dubai.
Awesome. So what is the core of your panels?
Closed cell polyurethane.
Okay, beautiful.
Charles, what are you doing right now with the fact that the industry shut down? You can't get any raw material.
I'm looking for raw material.
You're not going to get any for a while. You're going to be like all the rest of us and starve until April or May.
Well, we've got some pretty good industry contacts. I was greasing those skids yesterday evening, as a matter of fact. We're
able to get raw materials right now, and I hope that helps. From what I understand, all cash deals for raw materials are going to be on hold for about the next 2 to 3 months, which is hard to believe. Contract deals are still being honored. And so if you've got long-term contract
Yeah,
for
but all
receiving
that's
product,
under
you're still going to get it.
Yeah, but under allocation, you'll get part of the chemical you've ordered because the rest of it doesn't exist.
Yep. I can relate to that.
It's bad right now. You know, why would you ever think of winterizing?
What do
something?
you do, Josh?
Oh, what do I do?
Yeah.
Man.
What is bad? What is bad
do you
for
do,
you? I
Josh?
don't know with respect
So
where you're coming from.
I work for a spray foam installation company, but we're national, so buying power wise is pretty big. But I follow all this industry news as a somewhat of a sick hobby, and it's you follow Urethane blog. You want some really scary nighttime reading? Go to Urethane blog and read about what doesn't exist anymore compared to what used to exist as far as the raw chemicals go. And then, Scott and I can take you drinking as we try to figure out what we're going to do for the next couple months to make a living.
Yeah.
Josh, is it as
why I'm
scary as
drinking
The
now.
Handmaid's Tale or about on equal part?
It's probably the scariest thing I've read, to be quite honest with you. The only thing I can compare it to is The Uninhabitable Earth, which I read recently, where I add a chapter at a time, I'd have to put it down and go cry in the shower. This is like, the 500 metric tons of this chemical A that used to exist is down to 80% of that. Oh, I'm sorry, 80% of that is gone. So all the upstream materials that they make out of that, not just polyurethanes, but anything made of plastic, is going to have to wait until they remake it.
Why is it gone?
Where'd it go?
They shut their factories down and
Well, the smart companies, when the weather came, shut their factories down. A lot of companies were shut down, as in when the power went off, the whole thing crashed.
Some companies had their pipes burst,
Exactly. Scott can
like the
confirm
paint
this, like,
companies.
he's in a spray foam company. We can't keep our raw material colder than about 50 degrees, 55 degrees, or we lose yield. Well, like if you keep all of the chemical that you make this stuff at 18 for 3 weeks, you're probably not going to make anything out of it afterwards.
wow.
So some of the plants aren't even going to open back up for another week.
Yeah.
I mean, I can't think of a worse situation for a whole industry than it is right now.
Who are you buying your foam from?
What was that?
Who are you buying your product from?
Predominantly Huntsman and BASF, although they both declared first. Well, Huntsman won't declare a force majeure because they're stubborn, and I think they're trying to play some weird long game where they are afraid they'll push people to other markets.
Yeah.
Like, I mean, Covestro, Bayer, Dow, everybody else issued force majeure, so they can't even be sued. There's just no chemical out there. Huntsman makes almost all the raw material that everybody else buys to add the secret sauce to. And Huntsman owns Demilac, Lapola, and Isonine right now. So, and BASF they run a very lean business. They don't keep chemical in stock to turn into things. They run it through really fast. So,
Well, they're currently doubling their capacity when that should be online before long. You could check out Yantai Wanhua. They're one of the largest urethane companies in the world. They're out of China.
yeah, then my raw material would just be sitting on a boat somewhere outside of California doing a big circle for 2 miles forever.
That's the problem now. That's the
Yeah,
problem
they-
now. is this-
That company already has significant distribution operations in the United States. We've been using their ISO for over a decade.
Yeah.
That's
Sorry,
wild,
Jamie.
y'all. That's okay. Did you, the weather did that? The big weather in Texas?
Yeah, well, it's a little bit of both. I mean, some of the companies.
Yeah, it's the weather's fault.
Well, it's Texas's fault. It's the fact that they have their own
That's
independently controlled,
grid.
you know,
That
utility grid.
situation is what you're
Yeah.
saying. There was
And,
really,
you know, 10 years ago, they had a shutdown on a massive scale and they were like, we should never let this happen again. And then they didn't do anything to never let it happen again.
oh,
Right.
sorry, man. That's tough. Good luck.
Well, you know, whatever.
Yeah. I was literally reading a letter right before this call that was sent out from our ops manager relative to that very thing from one of our plastics companies.
Yeah.
I'm
Talking
telling
about
you,
Force
urethane block.
majeure and,
Look it up online. It is.
yeah, the pipes,
reading.
miles and miles of pipes and the plants are shut down and force majeure. And all the ugly things we don't like to see.
So all the things you guys are referring to is, I've been on calls for 2 days on MDI.
Yep.
Is in everything, pretty much in the construction industry that's glued together. A heck of a lot of it's MDI, and we at Huber use an enormous amount, 5, 6, 7 train cars at a time in the mills, and we are completely out. And it is on the way, but not sure when it's going to.
Don't hold your breath.
Well, it's also, you know,
Well,
think of all the things
with
that are made-
Advantech, we probably use more than anyone else on the MDI side. There's no secret to it. That's what makes the board better. And we have long time, 25 years been using it. So hopefully we've got some, we were fine until the Texas deal. We didn't have any problems with the hurricanes last year, none of that. But this Texas deal is a whole different thing when the plant, like you were saying earlier, was shut down for 8 or 9 days. They run it and get it out of there. They don't have any just stored up. So when you get a big interruption like that, it's going to cause a huge ripple effect in the construction industry.
Coop, is Stuart Brock in your office?
He's in Charlotte. Yeah, I'm out of Raleigh, but Stuart's in Charlotte. He handles our industrial side of things.
Yeah.
Good guy.
Yeah, he is.
Man. Ooh, thanks for sharing all that, you guys. This is we could keep talking about this for a good bit.
I'm glad it's not just me. I've had the same kind of week. It's been a nightmare.
Mm.
Well, real quick, I think we've welcomed a lot of most of our guests here. Mike Cap has just joined us. Danny, welcome. Thank you for joining us. Danny just joined us as a new member. So thank you for joining us today. Hi, Mike. Thanks for coming and joining us.
Sorry.
Well, you guys, it's right at 4, so we'll get started talking at least about the building envelope, assuming that at some point you'll still be able to make one. It'll happen, right? So we'll keep things, we're doing this Pecha Kucha or Pachachka or however you say it. Pikachu style presentation. So a lot of information pretty quickly and hopefully plenty of time for discussion and Q&A. And it sounds like there's plenty of questions and discussion. So hopefully we can leave you guys plenty of room for that. Selena, I have your slides. And
Okay.
so I can do that. And then I'm pretty sure, so I have just a check-in with all of the presenters here. I'll go ahead and share my screen and do some of these get some of these intros going. And then some of you guys are doing your own. Whoops, how do I make this? Do it. PowerPoint, there we go. So I know some of you guys will be doing your own presentations and we'll just talk it through. And then I have other folks have your presentations and so I can help run it. and we'll just enjoy the whole thing. So, welcome everybody. Thanks for joining us to the High Performance Building Council. And we are kicking off this year with our Path to Net Zero series, where in our educational meetings and hopefully with any luck, being able to meet again in person, before the year is out. But being able to share some more technical details on how to get homes energy efficient and the benefits there, and what does net zero building really mean. So in today's climate, really booming, and then all the challenges that we're seeing, there's a lot of room for high performance. And hopefully high performance folks to be pretty strategic and smart about how things approach. So,
Jamie, how do you perform high performance? You're with Southern Energy Management. You once told me, I forget when it was, but the typical blower door numbers you were seeing from homes in your area were in the range of 3 to 5.
Yeah, that sounds about right.
Are those high performance homes?
Well, since the house is a system, it's a component of it. So I would say anything going over 4 air changes per hour is going to be hard to label it that way.
Yeah.
Because air sealing details, we can certainly do better than that with a little more attention to detail and not a lot of cost. We might answer that question. So I'd like to see them perform better than that. But, there's a lot more than just air tightness that goes into the house, which hopefully we'll get to talk about a little bit here. Good question, Charles. Peppering me already. So you guys just heard from Charles Leahy with Eco Panels is one of our presenters today. We're going to be focused on the building envelope. Coop Jackson's going to talk to us about Huber advanced wall systems and the opportunities there. So working our way from the outside of the wall to the inside. Eric Holt, I'm super excited. He agreed to join us all the way from Colorado this afternoon and is going to give us a rundown on advanced framing systems. And then Josh was kind enough to be willing to talk air sealing and fiberglass insulation strategies. Scott will be focused on spray foam and giving you a little bit of rundown on that as a high performance insulation. And then Craig is joining us for some really cool movement in the glazing industry. So we're going to see the future of windows coming from Craig. And next, and click. Here we go. All right, Selena, would you like to tell us a little bit about what's happening in the future of the HBA?
Sure. So most of you know, as members, the DOC is an approved provider for the general contractors licensing CE. So we're offering classes throughout the year, and there's our schedule. So if you need to get your CE, please consider joining us for your classes. Those are the dates there. We also have the Green Home Tour coming up end of April, 1st of May. We have 18 entries, which we are happy with. We would love to have more, but we're happy with our 18. It's exceeded our goal. And those tours is a hybrid. The entries are hybrid where you can do in person or virtually. So it's a very good mix of each of those. And then also as an HBA foundation, we are doing our call for scholarship applications. So if you know someone or you have a rising senior or graduating senior, encourage them to apply. The foundation will be granting at least 10 $1,000 scholarships to graduating seniors in our area. So just something to think about and to spread the word about.
Thanks, Selena. I think one of those seniors is one of my neighbors, which I'm pretty excited to write a letter of recommendation for. So.
Oh, great. Good.
Can I put a plug in here for my recently retired partner?
Yeah.
One of the ways that we celebrated Leon Meyer's retirement was to set up an endowment for one of these scholarships to be delivered annually. So this will be the first year, in my understanding, that there'll be the Leon Meyer's scholarship going out. And I'm honestly pretty excited about that. And I think Leon is as well. So
that's so cool. I bet he is. And then finally, thank you to our sponsors. So the High Performance Building Council, to be able to do and support, tour, and really help generate, it's a volunteer committee, and without the help of sponsors, it's really challenging to get the information and the materials and just this certainly needed knowledge out there. So please take a moment and pat yourself on the back if you are one of our sponsors. You are changing things in the triangle. And if you would like to sponsor the High Performance Building Council, I'm sure Selena would gladly talk with you.
Yes, please. Yes, please.
All right. So first on our agenda, let's see here. Who's first? Is it Charles?
Yes.
We.
All right. Okay, Charles. So I believe I have your presentation, right? And you're going to.
Yes.
Cool. All right. Pulling it up right now. And Charles, if you'd like to
Just your view, have a clock so we know where we are on this whole 20 seconds a slide.
That's a great question. I don't know if it'll count down.
The slide will just change and you have to
It's
change with it.
automatic. You're correct.
We'll roll with it. That's good.
Yeah, it'll just do it for you. So while I'm pulling it up, Charles, if you don't mind giving a little brief intro of who you are.
So my name's Charles Leahy. I actually come from the tech industry. I got an undergraduate degree in applied physics and went straight into technology. Whether it was printed circuit board assemblies, microprocessors, silicon fabrication. I worked a lot over in Asia and lived in Silicon Valley for a while. I returned to North Carolina in the early 2000s. And a developer said, hey, you ought to check out this new high-tech building technology, structural insulated panels. And he said, I'll give you a 200 home development. Let's do this. And before you knew it, I had a factory doing it. And then the economy blew up in 2008. And the developer went bankrupt. So ever since then, I've been trying to make the product better. We've been innovating. I'll show you a glimpse of a new product we've got after my pitch. And yeah, we make the most advanced panelized building system on the market today. And I'd love to tell you about it.
Perfect. So can you guys see my screen okay? I believe it has started with, because I've clicked back a few times. Do you guys see?
Okay, we are in Mocksville. If the time has started, yeah, we're in Mocksville, North Carolina. We ship product all over the world. This is a representation of our basic panels. The thickness can vary, the size can vary, the height, but typically we don't do jumbo panels. We use market available building products like 4-foot wide structural rated sheathing. Now, when considering a high performance building, that didn't seem like 20 seconds. Where do you look for the greatest return? Heating and cooling is by far the largest consumer of energy in the building envelope. And so we try to address that. How do you mostly directly affect it? Well, you define the building envelope. And lots of times you get funky styles of homes and it's not clear where the building envelope will be established, but you got to define it. And then you want to use our panels as much as you can around it or other uses. So a tight and well insulated building can significantly or entirely reduce the requirements for an HVAC system, but yet 99% of the homes in America are built stud frame, which is the weakest and least energy efficient method of construction allowed by law. Now, in theory, again, my background's applied physics. In theory, we want a continuously insulated building envelope, no thermal bridging, really good insulation, and you would have virtually no energy loss if this was a perfect world. So this is what you want. This is what you get. And anybody's a John Lydon fan, you know where that came from. So simple thermal bridging of a house can reduce the performance of that wall system by 50% or more. That's per Oak Ridge National Labs. How do we build 99% of the homes today? Well, you're looking at it. Significant thermal bridging. You cannot have insulation and framing occupy the same space. So when you look at these homes through a thermal imaging camera, this is what you get. These are homes built by premier, quote unquote, green builders in Asheville, North Carolina. They're all green built certified. And, you know, these guys are singing their own praises, but they're not performing really well. And we believe there's a better way using better materials. So what do our wall panels need to do? What's the purpose of a stud? It's to provide structure, allow securement of windows, doors, attach switches, you know, temporary fire stop, big thing. And so what we're doing is we're trying to adapt existing products already in use in the market in a way to provide a better insulated building envelope that trades will be familiar with. You can mount the window the same way as with the framed wall. And the way this panel works, well, here are our corner panels. By patent, we have single piece corner panels. There's no structural thermal bridging at that corner. And here's a photo of 135-degree corner panels for a bay window. So with closed cell polyurethane foam as the bonding agent, we've got a bonding strength of around 50 PSI on OSB. It's actually 48, but that yields more than 5,000 pounds per square foot of adhesive bonding strength. So as an I-beam is how it works structurally. Now our foam is approximately, it's an HFO blown foam, so no CFCs, no HCFCs, no GDP. It's class 1 fire rated, and the R value or the insulation effectiveness actually increases as temperature decreases. So that should say 48, it says 38 there, my mistake. So the panels, when acting as a full structure, we're typically 2 to 3 times stronger than stud frame construction. And I think this video will play here. Here's the cam lock. We adapted this cam lock from the walk-in cooler industry. If you've ever seen a walk-in cooler go up for a grocery store or a restaurant. We've got one cam lock every 2 feet. And hot weather testing, we're actually passively cooling homes in hot climates like southern Texas, southern Georgia. You see with the different thicknesses of panels, how you have a different response with T in DT. Temperature changes in time. So with the 4.5-inch panel, we've got a more steep slope. With the thicker panel, we've got a more gradual slope as the temperature starts to rise. So stud frame construction, again, it's the weakest and least energy efficient. On the right side, you see homes on the exact same nights as the photos were taken on the left side. On the right side is homes better made with our panels. And you see the thermal performance there. So we'll leave you with this parting video, time-lapse video of our home going up in Western North Carolina in a cornfield. And it goes up in about 3 hours. It's a 1,200 square foot home that became a 2,400 square foot home because it was 2 stories. But you see the shadow of the sun moving across the job site. It's that quick. The panels are pre-numbered and they're just connected with the cam locks embedded in the sides of the panel. The blower door ratings that we're seeing people, builders have are generally almost always under 0.5 ACH50. We've seen in the teens, 0.19, 0.18 ACH50. And just as a part, this is the new product we just came out with. It won an award at the National Association of Home Builders show this past February that was virtual. It's a stackable block, R40 concrete block. Thank you.
Charles, way to be our first contender in the 20-second slide fire hose of information, but that was awesome. That's really good. All right. Who do we have up next, Selena? Coop?
Yep.
All right, Coop, I got you.
And Coop, we use a lot of your product actually on our panels.
I was gonna say that would be really good to put that on the outside and eliminate.
Well, pull up our website. You'll see it on the home page.
All right, good deal. I like that.
We're marketing for you.
Coop, if you could give us a little quick introduction, a little bio, and I'll pull up your presentation.
Okay. All right. I'm Coop Jackson. I am with Huber Engineered Woods. I've got Greensboro to the coast for Huber. And my background is pretty extensive here in the Triangle. I worked with Carolina Builders and Stock Building Supply for about 20 years. And I worked with BFS for a couple of years and then went to Huber. I'm in my 10th year with them now. So about 30 years in the construction industry here. And I've seen the very worst and the very best. And I don't know if right now is either, but it's been pretty incredible journey for sure. But so I know a lot of people in the Triangle, and you know, it's a great market to be in, no doubt about that.
Thanks, Coop. Sorry, this is the first time I've done this on the present.
Okay, you ready?
I think so. Let's do it.
Okay, so basically, I enjoyed that first presentation, and I have some of that towards the end. We have a zip product that is probably half of what he was discussing. But Huber is a privately held company, one of the largest in the country, back to 1883, and it's a global company with 4,000 employees in over 20 countries. 4 different, I guess, divisions. I work for the Engineered Woods division. We're based out of Charlotte. We actually have an Engineered Materials division, which is ingredients to enhance performance for paper and industrial products and consumers applications. And then we have a Resources Corp, which is just basically helps manage 600,000 acres of timberlands. Huber used to own all those or a lot of timberland, and now we just manage it for others. And then CP Kelco, which is in all the toothpaste is the biggest one there that I would say that they do, but they handle a lot of things. So we have 4 mills in the Engineered Wood division, and I'll try to run through them really quick. One's in Broken Bow, Oklahoma, Commerce, Georgia, Crystal Hill, Virginia, Spring City, Tennessee, and Easton, Maine. That's our 4 OS or 5 OSB mills in the United States. So we're an innovation company. In 1994, they decided to go away from just making regular OSB and make a high performance OSB. Advantech was introduced in 97. Zip was introduced in 2006. As you heard earlier, about 2008, the market crashed. So it was a long introduction of Zip, but just go up the timeline and you can see we came up with the longer length Zip. And then every year or every 2 years, we've come out with a better product. This year we have an Extreme Green. We acquired a company out of China called Extreme Green. And it is a fire rated panel that would be out next year. But the zip wall system is what we want to talk about now. So basically the number one question I get is what's the difference in the green and the red? The green is a 7/16 panel, no different than the red coating. They're 1/2 inch and 5/8. So only difference is the thickness. They can all be used for wall and roof structural sheathing. So basically the zip system gives you 4 things. It gives you the structural durability. It is an integrated water resistive barrier. So basically your barrier is already melted to the outside of the structural panel. It gives you a continuous air barrier as you seal it with our proprietary tape and or sealings. And then it does have speed and ease of installation. It's a two-step process, and you put up the board and you seal it and you're done. So that is the main thing, is it gets you a continuous air barrier and a water barrier all in one product. This slide just basically shows the two different ways to seal it with our tape on the right, and then with our stretch tape on the left, showing that, you know, hard to seal areas, you can use the stretch tape for window pans and or around round penetrations. So it is a system. It's not just the board. The system itself has a lot to do with the flashing and the sealing. Go ahead, Jamie. The liquid flash was something we developed several years ago. That's Matt Reisinger, for any of you that have seen him on Instagram. He has a huge following and he loves the liquid flash, but it's a product in lieu of tape. It is great. It is a product that might be cost prohibitive in some situations, but if you have a tough area to seal, this will certainly do it. It sticks to about any surface. It has a quick cure time, and it's also backed by our 30-year guarantee if you use it with the zip system. So the R panel is our zip system, our zip board with polystyrene or a polystyrene insulation on the back. And you get the same things on the outside. You get the continuous water resistant barrier, and then when you seal it, you get the air barrier on the outside, as well as with the foam against the studs, you do eliminate the thermal bridging for the most part, and you have the structural durability of the zip panel on the outside. One more. Okay, so the R sheathing that we have has really 4 different thicknesses: an R3, 6, 9, and 12. And then the panel thicknesses, it all depends on the number of how thick the polystyrene is behind it, and that gives you your R value. So mostly for this market, R3 and R6. I have done 2 net zero homes that were R12, and I've done a couple of multifamily projects that had R9 on some of the buildings. So that is pretty much it for my presentation. Pretty quick, but we're growing the zip business in this market out. I'm sure you've seen it, and it's a good product, and we're hoping to be able to continue that in these times that it is hard to manufacture right now.
Thank you so much, Coop. While I'm bringing up our next presenter, I believe, Eric, you're going to be next. And
Yep.
I have the slides that you sent.
That's
and I don't know
good.
if you have changed anything, and if you want to
No.
do yourself. Okay. So while I am bringing that up, and you guys, please, if you have questions, feel free to throw them up there in the chat. I see Kurt already has one.
Yep.
We were going to go through the presentations and then capture a lot of the questions just to try to keep ourselves moving along. So don't want to slight anybody, but definitely throw them up there in the chat so you don't forget, so that we can grab them at the end. Okay. And Eric, I have your bio, but if you would like to give us a little background on yourself, I'll bring up your presentation.
Sure. Merrick Holt. I'm at the University of Denver. I'm a researcher and a professor there. I got 30 years in the construction industry. I started out as a lumber sales for a lumber yard that's no longer in business. That's not my fault. That was back in the early 1990s. And then I got a job as a building inspector, plan reviewer for a local jurisdiction. And then I moved on to a multifamily custom semi-production home builder, and was a job site superintendent, babysitter. And then I started drawing house plans on the side and owned an architectural design firm up until 2006 was a great year. 2007, not so much. And so we sold the company and went and hid in academia while the market took a big old crash. And I went through the brain drain and the brain damage of grad school. And now I got a job at the University of Denver. And so here I'm teaching the next generation of professionals in the construction industry. It's a great position. If you guys ever want a second career, teaching's fantastic, especially in the academic world. So we're heavily involved. You can go ahead and start the presentation.
Okay.
I got the timing built into the slide, but heavily involved with the NHB student chapters, associate schools of construction, a lot of competitions. I teach construction building systems, materials and methods. I teach intro to architecture, how to read plans, and then I also teach estimating. So here's my contact information. We talk about advanced framing methods. I thought we should make sure we all understand what we're talking about. We're the structure of a home, the load path through a home, roof system, how they tie into floor systems, into wall systems, because all of these, as we look through the traditional way that we've built, are integrated together. And it's really good to understand that. Also, I know that we would love to see a different way of building homes. There is definitely more efficient, energy efficient ways, but stick building and light wood framing is the dominant way. I know our slide deck here only shows through 2015, but not a whole lot has changed even here to 2021. 99% of the buildings are done with light wood framing. We used to frame in post and beam framing, and there are still pockets of America that do it this way, but it's hard to get straight, really large chunks of lumber. You still got to infill the bays, and it takes a lot of high skill level to get the joints right. And so we've moved on from post and beam, and then we did a time in our country's history of balloon framing, where you had super straight 2x4s that could go from foundation to plate line for the roof. The challenge is you got all these little chimneys that run up and everything hangs on it, and you've got all that fire blocking that's got to put into it. City of Chicago and the history of their fire is because of balloon framing. And so now traditionally we build with this platform framing system. You build your floor system and you sheathe it. You build your wall system and you sheathe it. You build your next floor system and your next wall system, and then you drop your roof system on top of it. Well, all of those different systems have different spacing and different requirements of connection pieces. And so we have integrated into the system subsystems to help support all that. So a traditional framing has a single bottom plate, a double top plate. You've got studs, typically 16 on center is predominant how they put it together. You've got your headers and your cripples, depending if it's a door or a window. And so this is how a majority of homes in America are built. You get down into the nitty gritty details of how you've got your stud corners, typically a 3, sometimes 4 stud. How do you insulate that corner? You're always trying to figure out how you hang your sheathing and your drywall, and insulation at times gets left out. And so you create a cold corner or a hard to insulate corner, or the insulation doesn't go all the way in there. Same thing for wall intersections in traditional framing, where they tee together. You want to make sure, again, you've got a nailing for your sheathing and your drywall. Well, that a lot of times comes with a sacrifice on your insulation, and you get cold corners and cold connection points. And just to illustrate the different spacing, your studs are 16 on center, your floor joists or your roof system maybe 2 foot on center. So how do you accommodate that transition or that difference in spacing? Well, we do it with that double top plate to transfer the loads down when they don't align up. It adds a lot of extra wood and material into the framing system. Same thing for the corners and the tees, where we tie those top plates together to again integrate the walls together and tie everything structurally. There is a lot of extra material, especially in a non-load bearing wall, in that double top plate just to have a connection point. So there's like 30% extra material. When we talk about advanced framing, what we're doing is we're going through and we're engineering or thinking through systematically how everything integrates. Your roof system is 2 foot on center, drops down to a wall system 2 foot on center, to a 2 foot on center floor system back down to the walls. And so now your load path all stacks. Everything's on the same spacing. Thicker walls, like go to 2x6 instead of 2x4, integrated and relocate where your headers are and your openings. So now everything point load wise transfers down. You can eliminate a lot of material. And then on your non-load bearing or your gable ends, well, you don't need headers over there. You can just use regular cripples. Same thing then, conventional framing versus advanced framing. Your advanced has a lot less material in it that's needed, up to 30% on some homes, as some studies have proven. You get rid of a lot of extra cripples, extra support material, just things that were in there just to literally hold drywall or siding to the wall. So by integrating either drywall clips or sheathing at different locations, now you're able to provide the same type of nailers with a lot less material. And so just by thinking through a lot of your different details, you can get some very still structurally sound. They meet building code, the weakest and as Charles talked about, but it still works all the way through the system. Different ways to tie in your wall plates using strapping or just a minimal piece of blocking. So everything is structurally tied together still the same way, but without all that extra material. Same thing for framers, rethinking how you do your framers. Instead of the traditional double 2x material with a spacer, now go to a single framing depending on the load, or a engineered framing. And so you allow for more insulation in the house if you're not using like an eco panel or some other system like that. And the reasons that you might really seriously think about that: more sustainable. You get a highly insulated wall system. You can actually increase the actual overall total R value on your wall. And so that becomes a much better insulated house, even though you're still building with 2x4s, 2x6 and stick building. Here's the biggest thing right now that I think: the way that lumber prices have just skyrocketed and the volatility in the market, 169% since April. If you could reduce 30% of the material in your homes, how your home and your pro forma and your bottom line would be affected by that, and what that does for that house pricing. So here's resources where a lot of this came from: the APA, the Engineered Wood Association, and their website. You create a free account with them. You can download the full report of this. There's my contact information again. Thank you for letting me play in your guys' pool.
Eric, thank you so much. That was so cool. 30% less lumber. I feel like that's the tagline that could really get some folks' attention right now. Yeah.
Especially with lumber prices.
Smarter.
It's crazy.
It's wild. All right. Guys, as I'm navigating, it's taking up both my screens whenever I look for these things. So Selena, who do we have up next? Thank you, Eric. Oh, you're on mute.
There we go. Yep. Here we go. Josh, air sealing and fiberglass installation.
Okay, perfect. And Josh, I believe you're running your own show, correct?
Are you shy? If you let me share the screen, I'll do it from there.
Sounds good. I think did I
You
put
should be
your-
able to.
Yeah.
Just be patient with me.
I was doing the same thing. Like, how do I make it present?
So a little about me, just real quick before we get started, unless this thing's going to start, go ahead and tick off running it, which it might. My name's Josh Collins, work for Prime Energy Group. Like some of the other people that are already have already presented, I got in this business sideways. I've got a degree in botany from NC State. I worked for Monsanto and Bayer for 4 years doing plant genomics and genetics. Look at it, just running off. Stop it. Okay, so let's see what else. I was a stay-at-home dad for 3.5 years. I've been a mason. I've done rainwater harvest work. I currently teach for the HBA, several topics. When I got into this industry, I sealed crawl spaces and sprayed foam. So I've done the labor side of all this stuff, air sealed, insulation, fiberglass, spray foam. I've kind of done a little bit of all of it. Jack of all trades, master of absolutely none. What else? I hate cats. They're horrible for indoor air quality. I've seen that on slides about me. Somehow I ended up in a bio. I got saddled with the fiberglass insulation because Scott's going to take the spray foam, but I have been doing spray foam much longer than fiberglass. Started with Prime 11 years ago. We started Prime Energy Group in 2008. And at one point, we were spraying more foam than anybody else in North America. I think at least Icynene, one manufacturer. But I digress. From the beginning, fiberglass and air sealing for a high performance building envelope. It's a cheap choice. It is inexpensive in the days where everything is getting more and more expensive, although fiberglass pricing is going up. You can still hit your air exchanges with fiberglass bats and proper air sealing. But just real quick, the basics, heat goes to cold and pressures go from high to low and moisture goes from areas of high concentration to lesser. And that's important because that's why we're doing all this in the envelope in the first place. Just conduction, convection. We're not going to talk about radiation today, but those two, the conduction and convection, that's the big two with heat loss and gain. You're talking your conductive heat gain that's why we're putting the bats in the wall in the first place. So how do we deal with the conduction? You've got fiberglass insulation, properly installed ceilings, walls, and underfloors, reduces conductive heat gain and loss. You got to have 6-sided contact though. It has to be touching everywhere for insulation to properly work. So just like the image on your left, you want to have grade 1 install every time. Nobody should be charging you more in the market for a better install these days. I see it all the time in multifamily. This is not installed. That piece of fiberglass insulation is shoved into a hole. It is not insulating anything. I'm going to steal that little frowny face emoji and make it my background or just my head in all presentations. This is what you want to be looking for. You will see the duct strapping on garage walls because you should not be using craft face bats anywhere. Tiger teeth or insulation supports say every 16 inches on center on garage ceilings and underfloors. Otherwise, it will fall out. I'm faster than the 20-second slide. All right, there we go. But you don't have to just use fiberglass bats. You could use net and blow. Netting and blowing is a great way to get a full filled cavity because a garage ceiling is not a floor. It is a wall turned sideways. Why aren't we fulfilling it? Here's a good picture of yet again, garage walls with duct strapping, because this is the proper way to do it. Full filled cut around cavities, no craft bats. I'm going to say it over and over and over. Got to split around those wires and plumbing pipes. The top image is yet again. You don't do it like that. You're doing it at the picture at the bottom, although you don't have to move the wiring. I'm not sure why that worked. But yet again, I said it the last time, no craft bats. Craft face bats is a vapor retarder. And where do vapor retarders go in our climate zone? In your truck, unless you want to put it under your slab, which is the only place it should go. Convection. So there's air leaks. This is how we deal with everything else. Air infiltration, exfiltration is 30% of your loss and gain right there. That's how we tighten it up and get where we need to go at less than 5 air exchanges, which is unfortunately current code. 2009 energy code, we're just going off that, but even, it's moved from there. Sources of air infiltration, caulked, gasked, weather strip. Please no chinking anymore. We're not shoving bats in a hole. These are the places, your key air seal places, top, bottom plates, daylight. If you're doing advanced framing, then you have a lot less of these multiple penetrations and studs where you have daylight coming through. So, you caulk everything for an advanced framing package. You caulk all of it. Anywhere 2 pieces of wood touch, you want to caulk. This is a good image of a Dow gasket product that has replaced seal at your top plates. That gasket you can use anywhere you use caulk, top, bottoms, daylight, anywhere else. It is more pliable. You are doing this next task right here with your air sealing around your penetrations. It is not just for fire code. That is draft stop. Fire stopping is a blocking. This is actually stopping air movement in that cavity. And then when you're going to use bats in a wall cavity, you want to go ahead and insulate behind your boxes. All those should be air sealed. You want to have some fun, walk up to a plate, put your hand on it, feel the air coming through. Window and door foam around all your windows and doors. Yet again, that should be a no-brainer, but still you see fiberglass shoved in there some days, some places. I've even seen commercial projects still where they have chinking written on the plans. Why are we doing all this? Because water moves. Only thing you have to have is a pressure differential and a hole. That driving force, which is your air infiltration, exfiltration, is bringing moisture in the environment. Right now, North Carolina's at 5 air exchanges. What does 5 say? Leaky and drafty. Because if you're building code to code standards, you get a D. Congratulations, you passed. You didn't kill anybody. That's the end of my presentation. I did it.
You did it. Thank you, Josh.
You're welcome.
Oh, man. That's good. That was perfect. There's a whole lot of stuff. And a garage ceiling is just a wall turned sideways. I feel like
It is.
I love that.
Why do you insulate an underfloor or a garage without 6-sided contact? You telling me that the physics of bat works differently there? No.
You heard it here. You heard it here, people. Fill your garages all the way to the floor. All right. Thank you, Josh.
Or use spray foam. Scott, I just set you up.
You're good. You're a good man, Josh.
But we've worked together before. Some people don't know the time that we've put in together.
That's a long history ago.
It is.
And
I'm giving my screen back, right? Y'all have it back. I'm not in control anymore, hopefully.
We have it back. And Scott, I
Sure.
believe you're up next. So if you have yours up and ready.
All right. Share. Cool. I'm getting there. This is the
You're
first time
fine.
I've ever shared, so
I think we've all learned. We're all. Did you see the button at the bottom of the?
yeah, it wants me to I'm getting there. I'm sorry.
You gotta pick your screen. It's okay. The trials and tribulations of Zoom, and so we didn't. I think we're doing great.
All right. Are we there, Sharon? Can you see?
Okay.
Okay. Are we good?
Rock and
You're
roll.
good.
All right. Well, good afternoon, everybody. My name is Scott Jansen. I work for MPI Foam. We're a family female-owned spray foam installation company in Raleigh. And I'll give you the basic 401s on spray foam installation. Hopefully this will start to slide here in a second. Appreciate you all having me. All right. So the types of spray foam installation. One main type, we're typically what myself and Josh do. It's a sprayed applied foam. It's done by a gun. And this is primarily done in new construction and additions. It's typically what you see with spray foam. It's the guy with the hose with the gun that comes out. And that's typically the new standard of insulation with spray foam. You can also do a injection foam. This is great for using a hose to fill the tight or inaccessible areas. It's primarily used in older homes where you have no insulation on the exterior walls. It could also be used on masonry block and new construction, commercial builds, but typically you don't see that in residential new construction. So open cell, there's two types of open cell and closed cell. It's a two-part system. A side is isocyanate, B side is a polyresin. Typically weighs 0.5 pound per cubic foot. That's the industry standard. It's R's 3.7 per inch. Typically air seals at 2 inches. And one nice benefit about the open cell is it allows moisture to pass through. And then you have the closed cell foam. Again, it's A side and a B side, isocyanate and polyresin. It's typically in the industry, in a residential, it's 1.8 pound to 2 pounds, R7 per inch. Air seals at 1/4 inch. Provides great structural strength. And it's a great vapor barrier as well. So what are the benefits of spray foam? Well, it's extremely efficient, expands to fill all gaps, and it's a great air sealer. There's a picture that's on the right. It's taken a hot summer day, probably 9 degrees outside. That's foam there on a thermal camera. And 9 degrees outside in the attic, it's only 80, which is fantastic. And continued benefits of spray foam insulation. It's a great sound barrier. It's not as good as rock wool or mineral wool, but it's a great medium as far as sound barrier. It reduces dust and pollen, so it helps with that. Which with wives love that, reducing the dust in the house, and it also improves comfort throughout the whole house. And continue the benefits here. It's of open cell. It's more cost effective than the closed cell. Can easily be removed compared to a closed cell foam. It allows moisture to wick through, and it's a great soundproofing option. And the benefits of a closed cell foam insulation, it can be left exposed. If you leave it out in the sunlight, you do want to put a coating on top of it so it's not deteriorating by the sun. It's a great vapor barrier, can achieve higher R values per inch, so you might be limited on a depth on the joist to achieve prescriptive. And also, again, provides a great structural strength. So the areas we spray on new construction, I mean, it's pretty much the whole envelope. You got the exterior walls, the garage ceiling, the gable ends, the roof deck, and the floor system. It's a nice full envelope and getting great results on efficiency and on a HERS rating as well on that. And for retrofits, we typically are using spray foam on exterior walls and roof decks. That's typically where you'll see it. Sometimes bonus rooms with the garage, and you do the garage ceiling as well, but lots of times that's sheetrocked, and so hopefully they already have fiberglass. And to Josh's point, filled with the garage ceiling completely. For existing homes, we're really just doing roof decks, and that's really where you can get the biggest bang for the buck is by spraying the roof. It's typically not your windows that need replacing, it's your attic that needs the help. With the spray foam in your attic, you're reducing the stack effect, which is greatly reducing the outside air from coming in because you're minimizing it from releasing out of the attic. So closed cell, where do we use those? A lot of metal buildings. We do a lot of metal buildings, shops, farmers, metal buildings store tobacco. We've done it for fruits and vegetables. I had a gentleman that has about 6 BMWs. We did his whole metal building. You can leave it exposed. It's a great option. Also, we use it along masonry blocks with the closed cell foam in basements primarily. It allows, again, another vapor barrier if there's any moisture that possibly can wick through the block if it's not properly waterproof from the outside on the foundation itself. So we're typically using it a lot on masonry blocks. We do a lot of sealed crawl spaces as well. This is a very tall crawl space, but it's a 10 mil plastic on the ground and then a closed cell foam on the foundation walls, leaving a termite viewport. You can also use a rigid foam board as well. Let's see, going almost 20 seconds. Are we getting there? Close. We use a lot of closed cell foam on wine cellars. We do a lot of high-end wine cellars. That's very popular with a lot of our custom builders. The wine cellar is completely enclosed with closed cell foam on the exterior walls, the ceiling, and the floor, creating its own envelope, if you will, to maintain those great temperatures for your $100 bottles of wine. And you can use a lot of closed cell on exterior commercial buildings as well, on the outside. And it's a great product. And I think that's almost it. Well, I think that's my last slide. Hope you all enjoyed the quick, oh, no, it's not. I lied to you. Sorry. The potential downfalls of foam is primarily cost. The open cell and closed cell is going to be double the cost of fiberglass, at least, if not more. Fiberglass meets code. However, it's not as efficient as foam because it doesn't air seal, but it is typically half the price. So a lot of track builders will do fiberglass just to pass code. Another potential downside of foam, if it's not correctly installed by a professional, the foam may not bond correctly due to incorrect mixtures or temperatures, and it could pull away from the joists and have potential smells. But that would be solved by having a great crew like we have, as well as other competitors that I work with. So thank you all for your time. Again, I'm Scott Jansen, MPI Foam. It's my cell and my email if we could help with anything. Thank you.
Thank you, Scott. You guys doing great, made it through. We're zeroing in on our final presenter. And so now we're down to Windows. And Craig, I believe you also have your slide deck. Is that correct?
I do.
Okay, wonderful. So if you'd like to get that going, and y'all remember, don't forget to, I hope you're either writing your questions down or throw them up there in the chat. Go ahead and take it away, Craig, if you're able to share your screen.
You got it. Let me see if I can do that effectively. Oh, I think I shared the wrong one. Sorry about that. Bear with me here.
We see your, it looks good to me.
I think you're seeing the presenter screen, no? Oh, okay, good. Then we're in the right place. I'm Craig Meyerhofer. Thanks to the council for having me here today and for David Finch for making that offer. I appreciate being here with you guys, and I'll try to be quick. I'm with Alpine High Performance Products. We're a manufacturer of passive house windows and doors, first certified passive house windows in the US. And the company's been around for about 40 years, making innovative high performance fenestration products. A little bit about us. Again, 40 years of working with suspended coated film and insulated glass manufacturing. We're about 50 years, or 50% residential, 50 commercial. We have two products that we manufacture. We have a fiberglass line called our Zenith series. And then we have a European style window, which is a UPVC, but it is a fiberglass reinforced for extra strength, called our Tyrol series. And both of those series go all the way up to R10 performance, NFRC certified. So very high performing windows, kind of entry point at R5 and going all the way up to R10. Big history and innovation. And we started working on thin glass, which my presentation is about today, in 2018 with the Department of Energy. Thin glass to us is 7 millimeters to 1.3 millimeters. Here you see a typical double pane, old style true triple pane, and then what it looks like with thin glass. And of course, just to show you what our suspended coated film looks like. So 3 to 4 times thinner than residential glass and 6 to 8 times thinner than commercial glass. Two types, vertical casting on the left there. Corning is the primary manufacturer of vertical casting, and then horizontal casting as well. Pilkington is our major supplier on that end. So when you think about thin glass, think about what you have on your iPhone, what you have on your TVs at home, solar panels. Some of the considerations are issues with tempering and access to low E-coated thin glass, and those are the challenges right now. The big advantage is the weight difference. If you take a 20 square foot window, if you add a traditional 1/8 inch thick center pane to that, you're basically adding about 48 pounds of weight. Well, with thin glass, that is lowered down to about 6.5 pounds of additional weight. So that's significant in terms of both the installation process, as well as the long-term wear and tear on the hardware on your product. Our experience to date with thin glass, there's a couple of major organizational biases. It's going to be difficult to work with. We found that to be completely wrong. And then fragile and easy to break. Wrong as well. It's kind of has very similar to almost a plastic, a very thin plastic. But we've found as we work through different areas of validation, no problem with thermal stress testing, physical durability, reflectivity, passing in all of these areas, handling, cutting, drilling, spacer application, got it all figured out. And then customer related feedback has been exceptional and without exception. Supply channel work has been good. Unlike plastics right now, we still are getting well fed on thin glass. And we've got product certifications and field installations that we'll get to in a couple more slides. I'm going to see if I can make this. Yeah, it looks like it's going automatically. So this was a test that we did where we were trying basically to break the glass. We did get failure at 240 miles an hour, and you'll see in just a second as that glass breaks. This was in a controlled environment. Don't try this at home. 240 mile an hour wind finally, but I will say that the breakage occurred on the outer pane first, the inner pane second, the room facing pane second, and then the thin glass in the center of that 50 square foot triple pane unit. The thin glass was the last to break. So pretty cool visual there. This is just showing some of the demonstration projects that we've done. Again, this is very new. We've only launched it as in our product lines within the last few weeks. But we have been doing demonstrations in conjunction with PNNL, which is the Pacific Northwest National Lab, Lawrence Berkeley Labs, Department of Energy, NYSERDA out of New York. So we've been engaged to do various different demonstration projects around the country to demonstrate the energy efficiency of utilizing a thin triple unit in the marketplace. Potential durability improvement, non-structural. It's not a structural area. It's not structural. It doesn't create edge-to-edge IG combination. So it's sort of floating in the center of the IG. It's more flexible, like I said, almost like plexiglass. And really being able to utilize a warm edge spacer on the inside of the IG gives us a tremendous difference in terms of how we're able to insulate the window product as a whole. And I'll show you some NFRC numbers on the very last slide. And then far lower embodied energy. It still takes roughly the same energy to make, but when you think about thin glass and how many square feet you can make with the same amount of materials, it's about 5x times what you make with traditional glass. And then this is a pretty busy slide, but it does sort of give you some ideas. So if you look, this is our NFRC data for our ZR6, which is sort of our entry level window. If you see our fixed low profile with our suspended film, and then if you look at it with our thin glass, here are your R values for low, medium, and high solar heat gain packages. We're gaining considerable amount of U value and R value through the utilization of thin glass. When you look at the center of glass, there's not much difference here in the U value, R value at center of glass. So that's really all related to that warm edge spacer and what we're able to accomplish through the use of that warm edge spacer. So significant improvement on U values, but we're offering the thin glass options at the same price as our traditional suspended coated film. That is I think I went a little bit longer than 6 minutes, but pretty close. Thank you for your time. Appreciate it.
Thank you,
And let me
Greg.
stop sharing. I can figure out, there we go.
Awesome. So thank you, man. That was good. So you've only had those windows a few weeks, it sounds like, in your market.
Just the glass package, utilizing thin glass in the center pane. We've been working on it for a couple of years with the DOE, but we've just now formally launched it in 2021.
That's exciting.
Yeah.
Second thing you've heard here first, folks. Good job showing up today.
That's right.
All right. Well, thank you so much, everybody that has presented. That was really informative and really awesome. And also a whole lot really fast, which I do see we recorded it, which is exciting. So if you feel like you want to slow that down and get all that information again, it will be available to you. I see some folks popping up in the chat. And so let's go ahead. I see Kurt and Randy both have questions. So Kurt, if you want to jump in and just go ahead and ask, and we'll go to Randy next, and then just open up the floor for questions. If you're still with us, Kurt.
I'm not sure if Kurt's still with us. So his question was to Charles, what is the carbon footprint or embodied energy of this product upon delivery to the site?
I don't know.
There you go.
So there are studies out there. We've got documents from actually BASF, who is a major provider of polyurethane products across the globe. Their German headquarters did a study on it and found that there was a 100 times return on investment for using petroleum products for insulation as opposed to using it to produce energy, consuming it to produce energy. And so the fact that we've got zero global warming potential, zero ozone depleting potential, and we, one of the things we talk about when we, or we don't talk about when we talk about our product is, people want a quickly recyclable product. That is not our product. It is a thermoset product. Once you apply closed cell urethane, it's there for 10,000 years if you don't let it be exposed to ultraviolet light or other incredibly harsh chemicals. But what that tells you is you can have a home that will defy moisture, defy rot, defy all these elements that will break down a typical stud frame home that has a lot of air infiltration, moisture infiltration, and that home will last longer. We talk about minimal home lifespans of 100 years, and we have, Eric, you're out there in Colorado. Craig, I think you're in Colorado too.
That's
so
correct.
We have homes that were erected in Chicago, and then taken apart and moved to the town of Berthoud, Colorado, part of their habitat program. And that was actually the third time being erected and broken down. So when we talk about recycling product, you can disassemble panels from one house and reassemble them in another house. And so the carbon footprint discussion is kind of complicated when you can live forever and conserve energy, almost forever.
That's a great answer. The next question.
What are the tall wall limits with eco panels? Are they stackable?
We've done 40-foot multiplex movie theaters dividing walls instead of concrete, which has incredibly large global warming impact. We've worked with the developers to create tall wall arrays with the 2-inch air gap in between that, divides George Lucas brand THX theaters. So, and that's a curtain wall assembly or an infill assembly around a steel frame. We're doing work in Antarctica now where I think the walls are 50 to 60 feet tall and the winds we're looking at down there are 150 miles an hour. So those are multiple panels stacked in a vertical array. It's a running bond pattern, almost like a brick. Well, it is a brick pattern. So the limitations are only there from your imagination.
Thanks for that. Appreciate it. I was just thinking about design flexibility, looking at your site as well. So I'm not unfamiliar with your panels. So
we can do curved panels. We can do a variety of different siding materials, like we use Huber Zip very commonly. We use, we've had a number of homes built, even in Fine Home Building magazine, with the LP Smart Side exterior siding product. And they're finished off in a board and batten, very attractive style. 30 to 40% of our clients are not builders. They are DIY people that are owner builders. And, if we are doing anything, we're trying to eliminate the cost of bringing in a high performance builder to build a high performance home. We believe that we can democratize the availability of high performance homes by reducing the skill level required to erect that home.
A little bit like Habitat using volunteer labor, which I think is.
And we've worked a lot with Habitat. I've got a question for Craig.
Perfect.
Craig, Alpin using Cardinal glass, and so we work. A lot of our people are super serious into high performance homes. And after a wall system, windows are their next greatest opportunity. Fenestration. And how would you compare a double pane glass with Cardinal glass to a triple pane without Cardinal glass? And would they be similar in performance? But obviously, I think the triple pane is going to be more expensive.
Well, I think are you talking about an insulated glass unit made by Cardinal? Because there's multiple business units of Cardinal. We actually use Cardinal's float glass in the manufacturing of our insulated glass units. Okay. They have a plant right here in Loveland, which is right next to Berthoud, which you referred to a few minutes ago. So we take quantities of float glass, 1/8 inch, 3/16, 1/4 inch, and then we manufacture our insulated glass units from that float glass. So I'm not as familiar with what the performance is of their double pane insulated glass units, but my guess is that if we were to take their insulated glass unit and put it into our window system as a double pane, we're going to get somewhere in a 0.25-ish U value, or an R4 window, maybe R3.5-ish. And our entry level, utilizing either suspended coated film as the third pane, and we actually do quad pane as well, quad glazed, or using a thin glass with, as I said, that warm edge spacer, which has a tremendous effect on the performance. We're going to start at a 0.19, 0.18 U value.
Are you doing any Krypton, Phil?
We do. So in our, we have a 7-inch, we typically do 1 3/8 inch IGs, but we do a line that's 7/8 inch as a triple pane. And the gap is so small in that airspace that we have to use Krypton in that. And then when we do a quad pane unit, again, you have the 2 outside panes and then the 2 inside panes, which we're doing either with suspended film or now thin glass. And those air gaps are so small inside of that Krypton is a much better performer than argon is in those situations. But I'm all too well aware of the Krypton price that's occurred. Trust me,
Yeah.
it's been painful.
You guys, I just want to call attention to the time because I do want to make sure everybody, thank you so much for joining us today. And if anyone has, I believe we typically run to 5 and often run over in order to allow conversation. So if you have any other questions, if you're wanting to throw anything in the chat, or if you do need to leave, if you'd like to say anything before you need to go, I just wanted to make sure and say thank you so much. And you'll be getting a list of all the attendees, who was here, who you met, as well as, well, I guess Selena and I will figure out how to share the recording. We haven't figured that out, but
I got it.
it'll be available.
You'll get it.
Thank you all very much. Charles has to bug out.
All right.
Thank you,
Thank you so much. Thanks, everyone.
Thank you very much, Charles. Cool. If you guys are staying, feel free to ask some questions or talk to each other. We're here for you.
No, we're just gonna sit here in this silent void, just keep each other's company. Let's just all sit here together. We can talk about the state of the industry.
I too
Go-
have to. I
Go
just wanna
grab a
thank
beverage if
everybody.
we're going to do that.
Great
Right.
presentations. Thank you all.
Thank you.
See you
Gotta
guys.
go, but
Yeah.
it's good to
If
see you
there's no
all.
more
And I've been
questions. Thanks, guys. Appreciate the opportunity.
Absolutely. Thank you, Craig, for the last minute jump in too. That was awesome.
Thank you.
Thanks,
Bet.
thanks
Take
for
care.
joining us.
You letting me present.
Thank you, Josh.
Mm-hmm.
Thank you, Craig.
Thank you, Eric. All right, Selena.
Thank you.
Good
Woo!
Woo!
Rocked it. I'll call you tomorrow.
Sounds great. Have a good rest of your day.
You too. Bye.